Three-cylinder engine. First widely used in DKW cars in the 1930s, the three-cylinder engine regained popularity thanks to its compactness and efficiency. This configuration makes it possible to create lightweight and fuel-efficient vehicles ideally suited for urban driving cycles. In this layout, the three cylinders are arranged in a single row. The main engineering challenge is suppressing first-order vibrations, since the lack of perfect balance creates a characteristic shaking effect. Modern solutions, such as asymmetrical flywheels and balance shafts, have significantly improved smoothness. Thanks to their small displacement, often from 1.0 to 1.5 liters, and the use of turbocharging, these engines can produce power comparable to four-cylinder units. Inline four-cylinder engine. This is the most common configuration in the world, used in approximately 70% of all modern passenger cars. The concept was popularized by Henry Ford in the 1908 Model T, where the simplicity of the design made mass production possible. In this layout, all four cylinders are arranged vertically in a single row. The main advantages are compactness and low manufacturing cost, as only one cylinder head is required. Technically, such engines suffer from secondary imbalance of inertial forces, which creates vibrations in engines with displacement above 2.4 liters. Despite this, modern balance shaft systems make it possible to achieve a high level of smoothness. The sound profile is characterized by a steady hum, lacking complex harmonics. Diesel engine. Patented by Rudolf Diesel in 1892, this type of engine operates on the principle of compression ignition rather than spark ignition. The compression ratio in diesel engines reaches 22 to 1, which provides thermal efficiency of up to 45 to 50%, surpassing gasoline counterparts. Diesel engines produce 30% more torque at the same displacement, making them indispensable for freight transportation and SUVs. The main components are the high-pressure fuel pump and common rail injectors, which deliver fuel at pressures of up to 2,500 bar. Despite the environmental scandals of recent years, modern SCR aftertreatment systems using urea make it possible to reduce nitrogen oxide emissions by 90%. V-shaped six-cylinder engine. The first production car with such an engine was the Italian Lancia Aurelia in 1950. The configuration consists of two rows of three cylinders arranged at an angle, usually 60 or 90 degrees. Such an architecture is significantly shorter than inline counterparts, which allows powerful units to be installed transversely in front-wheel drive platforms. V6 engines provide a more complex, rich acoustic profile and are characterized by high torque density. In sports models, the use of twin turbocharging turns the V6 into a high-performance instrument, capable of competing with V8 engines. The main engineering challenge remains the suppression of vibrations arising from the odd number of cylinders in each row. Boxer engine. Patented by Carl Benz in 1896 as the Contra motor, this unit is distinguished by the horizontal arrangement of the pistons, which move toward each other, resembling the movements of a boxer. Such a layout provides perfect primary balance and the lowest possible center of gravity for the vehicle, which is critically important for handling. Today, the main adherents of this technology are Porsche and Subaru. Due to its width, the engine requires a specific engine bay layout and a more complex lubrication system. The sound of a boxer engine is unique because of the uneven firing intervals in the exhaust, creating a characteristic rumble. Cooling efficiency in such engines is higher due to the large surface area of the block. Wankel rotary engine. Invented by German engineer Felix Wankel in the 1950s, this engine is completely devoid of pistons, performing reciprocating motion. Instead, A triangular rotor rotates inside an epitrochoidal chamber, carrying out all 4 strokes in a single revolution. The main advantage is incredible specific output. A 1.3-liter engine can produce more than 250 horsepower without forced induction. The Japanese company Mazda became the only manufacturer to bring the technology to the mass market in the RX series models. The engine is distinguished by the absence of vibrations and the ability to instantly reach high revolutions, up to 9,000 per minute. However, low thermal efficiency and rapid wear of the apex seals make its operation expensive and complex. Inline 6-cylinder engine. This architecture is considered the benchmark of engineering balance. First used by the company Spyker in 1903, it reached its peak in models by BMW and Mercedes-Benz. Thanks to the fact that first and second-order inertial forces cancel each other out, the engine operates with exceptional smoothness comparable to a turbine. All 6 cylinders are arranged in a single line, making the engine very long and complicating its installation in compact cars. The characteristic metallic sound at high revolutions and the linear power delivery made it a favorite among enthusiasts of sporty driving. Modern versions are often equipped with mild hybrid technology to reduce fuel consumption while preserving classic dynamics. V8 engine. Created by the French inventor Léon Levavasseur in 1902 for aviation, this type of engine became a symbol of American automotive culture. The configuration consists of 2 rows of 4 cylinders, arranged at a 90-degree angle. There are 2 types of crankshafts: cross-plane, which creates the characteristic low-frequency growl of muscle cars, and flat plane, used by Ferrari to achieve high revs and a shrill sound. The V8 provides enormous torque already from idle speed and possesses high reliability, thanks to the distribution of load across 8 combustion chambers. Despite the global trend toward smaller displacements, the V8 remains the standard for heavy SUVs and supercars. V10 engine. This type of engine is relatively rare and is often associated with high-performance sports cars and supercars. The first mass application of the V10 was in the Dodge Ram in 1994, after which it became firmly established in models such as the Lamborghini Gallardo, Porsche Carrera GT, and Audi R8. The V10 configuration consists of 2 rows of 5 cylinders, arranged at an angle of 72 or 90 degrees. It combines some of the balancing advantages of the V12 with the compactness of the V8. The sound of the V10 is incredibly aggressive and unique. Differing from all other internal combustion engine configurations, which makes it a favorite among car enthusiasts. However, its high production cost and increased fuel consumption limit its application. V12 engine. First installed on a racing boat in 1904, this unit became the pinnacle of luxury and technical perfection. The configuration consists of 2 rows of 6 cylinders arranged at a 60-degree angle, which ensures absolute balance of all forces and moments. This is the only type of engine that does not require balance shafts, even with extremely large displacements. Rolls-Royce, Lamborghini, and Ferrari use the V12 as a symbol of status and uncompromising power. Due to the large number of components and the high cost of materials, such engines are produced in limited quantities. The sound of a V12 is often compared to operatic singing because of the high firing frequency, which creates a continuous symphony of power. V16 engine. This is the pinnacle of modern engine engineering, used exclusively by the Bugatti brand in the Bugatti Veyron and Bugatti Chiron models. Introduced in 2005, the 8.0-liter engine consists of 4 rows of 4 cylinders, combined on a common crankshaft. For stable operation, the unit requires 4 turbochargers and an extremely complex system of 10 cooling radiators. Power output reaches 1,600 horsepower, allowing speeds of over 400 kilometers per hour. Fuel consumption under maximum load reaches up to 190 liters per 100 kilometers. This is the most complex and expensive mass-produced internal combustion engine ever made, representing an engineering triumph over the laws of thermodynamics. Electric motor. Although the first examples appeared as early as the 1830s, their mass dominance began only in the 21st century. Unlike internal combustion engines, an electric motor delivers 100% torque from 0 revolutions per minute, providing instant acceleration. The efficiency of such systems exceeds 90%, while the best gasoline engines barely reach 40%. The main types are induction motors and permanent magnet motors. They are practically silent, have no frictional parts in the combustion chamber, and require minimal maintenance. The evolution of lithium-ion batteries has allowed modern electric vehicles to travel more than 600 kilometers on a single charge, completely changing the landscape of the global transportation industry. Hybrid powertrains. These are modern systems that combine an internal combustion engine with 1 or more electric motors. The concept of the hybrid vehicle first appeared in 1900, thanks to Ferdinand Porsche. Modern hybrids are divided into mild, full, and plug-in hybrids. They make it possible to significantly reduce fuel consumption and harmful emissions through energy recuperation during braking, shutting off the internal combustion engine while idling, and driving on electric power at low speeds. The Toyota Prius, released in Japan in 1997, became the pioneer of mass-produced hybrids. The efficiency of hybrid systems continues to increase, offering a compromise between driving range, dynamics, and environmental friendliness under growing demands for cleaner air. Gas turbine engine. This type of engine, also known as a turbine, is a jet engine adapted to drive wheels. The first experiments with gas turbine-powered automobiles were conducted as early as the 1950s by Rover and Chrysler. The operating principle is based on compressing air, heating it through fuel combustion, and the subsequent expansion that spins a turbine, which in turn drives the transmission. The main advantages are incredible smoothness of operation, compactness at high power output, and the ability to use various types of fuel. The disadvantages include high fuel consumption at idle, slow throttle response, and extremely high operating temperatures. Today, they are used mainly in aviation,